All right, guys, so we're back solving some quadratic equations. We had spent 3 days talking about solving quadratic equations by factoring algebraically. We came back to our linear quadratic system algebraically now that we knew how to solve by factoring. So now we're going to spend the next 4 or 5 days talking about some word problems. So the topic here says picture frame problem. That's kind of like our goal. We're going to move towards this kind of sophisticated problem called the picture frame problem, which we had looked at a little bit in passing here and there. So we're actually going to start with some more basic ones. And then over the next couple of days, we'll start to get to what we call our picture frame and our walkway problems. So today's going to be more about number relationship problems, consecutive integer problems, perimeter, and area problems. But before we do that, so let's take a look at something that we haven't looked at yet. Let's look at number 3 from the do now. So this is something that has showed up here and there on the Regents. And it's not something, I mean, it's a quadratic, but it's not one we've really looked at. So what we probably want to do is we'd want to cross multiply. So I'm going to take my cross products and set them equal to each other. All right, so that tells me that x plus 5 times the quantity x minus 2 is equal to 6 times 3. So I'm just going to combine the like terms, right? Obviously, when we do this, we get x squared plus 5x minus 2x minus 10, which is really x squared plus 3x minus 10 is equal to 18. I'll add negative 18 on both sides, which gives me x squared plus 3x minus 28 equals 0, right? Because we always want to put our quadratic in standard form. I can factor as quantity x plus 7 times x minus 4. Now we use our zero product property, so either x plus 7 is equal to 0 or x minus 4 is equal to 0. So one of my solutions is x equals negative 7, and the other one should be x is equal to 4. So my solution set should be negative 7 and positive 4. Right? And especially with problems like this, we really should go back and check, because if we end up with substituting a denominator that becomes 0, that actually would be, that solution would not be valid. And we'll talk about what that means as we see it. So if I check negative 7, on the left, my fraction would be negative 2/6, and on the right, it would be negative 3/9, which if we simplify are both negative 1/3. And if I substitute 4 on the left, I get 9/6 is equal to 3/2, and both of them are equal to 3/2 if we simplify. All right, so this is just going to be a refresher of something that we did only one of 2 days ago, right? So we had done one cubic equation when we did our special cases. So I figured we should do another one. So we said we're going to factor out the GCF, which is x. And again, this is why we spend so much time on factoring completely. Now we factor the trinomial as the product of two binomials. And we use our zero product property 3 times. And we said the largest power tells us how many solutions or how many roots we could have. So in a cubic equation, we would expect that it's possible that we have 3 roots. And in this case, we do. And the 3 roots are negative 2, 0, and positive 9. All right, now something that we did not see yet. And again, I know that we're talking about word problems for these last few days, but these are kind of problems that didn't really fit into day 3. We just didn't really have enough time. So if we remember, we don't have a GCF here, right? Because there's a constant, so that we can't have a variable GCF, and the coefficient of x to the 4th is 1. So we don't have a numerical GCF. So hopefully we remember. I think the last 3 or 4 questions on our factoring test were of this variety. We're going to factor it down normally, except we're going to use x squared and x squared instead of x and x. And we said if I have a binomial here, I could possibly have a difference of 2 squares. And in this case, we actually have 2 difference of 2 squares. And again, going back to something I said a few minutes ago, right? We said the largest power here, right, tells us how many solutions we could have. So it's possible for me to have 4 solutions, which is actually what we're going to end up with here. This is going to get a little tedious solving these equations, but I'm going to use the zero product property 4 times. So I get x is negative 3, I get x is positive 3, I get x is negative 2, and I get x is positive 2. And if I want to streamline that in my solution set, I can put plus minus 2, and then plus minus 3. Or if you really want to write it out, negative 3, negative 2, 2, and 3. And all four of those solutions will check if you were to substitute them back in. All right, so let's start to talk about our quadratic word problems here, right? So it says 10 less than the square of a number is equal to 2 more than that number. So we don't have to go too crazy with something like this with the let statement because it's just a number, right? So if you really want to, I guess you could say let x represent the number. I don't think we really now have to go that far, but something that is really important that we have not seen yet, I don't believe in any capacity, is this. Find both solutions, right? So as we know, quadratic equations will typically have two roots or two solutions. Now in a word problem, we need to consider that both of those could be valid. Now if we're talking about a real world problem, generally the negative value is not valid, depending on the context though, and we'll talk about that. But we should expect to get two solutions. So depending on the nature of the problem, they may both be valid, or maybe one or maybe none of them will be valid. So let's solve it. 10 less than the square of a number. So I'm just going to stop right here, right? So that's x squared minus 10 is equal to 2 more than that same number. So I've got my equal sign. All right, that's a pretty simple equation, right? X squared minus 10 is equal to x plus 2. So I add negative x on both sides. I add negative 2 on both sides. That should give me x squared minus x minus 12 equals 0. That should factor down as x minus 4x plus 3. All right, now we can cut to our zero product property. So x minus 4 is 0, x plus 3 is 0. So one of my roots is going to be x is 4. And my other root is going to be x is negative 3. So we're not going to write this as a solution set, okay? We're actually going to write it out as the solutions are. And we would say negative 3 and 4. So let's think about it. 10 less than the square of the number is 2 more than the number. So let's consider negative 3, right? What's 10 less than the square of negative 3? Well, the square of negative 3 is positive 9. 10 less than that is negative 1. And that's 2 more than negative 3 because negative 3 plus 2 is negative 1. So that actually will check. And if we check 4, 10 less than the square of 4, 4 squared is 16, 10 less than that is 6, is equal to 2 more than 4. Well, yeah, 6 is equal to 2 plus 4. So we should at least check in the context of the problem, right? As we've said all along here, if you make an equation, there's no guarantee we made an equation that's actually consistent with the problem. We want to actually go back and work through the context of the problem, which we did. The solutions are negative 3 and positive 4. All right, so this one is going to be a little bit more significant as far as the solution. So it says we've got 3 numbers that are consecutive integers. So there's a lot of work that we're going to have to do after we solve the problem. So 3 numbers are consecutive integers. The product of the smallest and the largest is 11 less than 7 times the middle. What are the 2 sets of integers? That means we're going to get 2 distinct different sets of integers. So the last one, it was just 2 numbers, right? Whatever, negative 3 and positive 4. Now we're going to get 2 sets, as in like 8, 9, 10, and negative 11, negative 12, negative 13, and they both will be valid. All right, so when we're talking about consecutive integers, we generally will do x plus 1 and x plus 2. Now, that's not always going to be the case. That's why you'll see it in the textbook. But we said, you know, in some cases, we're going to switch these things around. In other words, if I'm taking the sum of the numbers, I'd prefer to make x the middle one, because then the constants will net out, especially if I had like 5 numbers or 7 numbers. If we have to multiply numbers, we may want to make the middle one x also if we have to multiply, let's say, the first one and the last one. But since this is the first one we're doing, let's keep it pretty simple. X plus 1, and x plus 2 are my integers. The product of the smallest and the largest. So I'm just going to stop there, right? Product of the smallest and largest. So my smallest is x, and my largest is x plus 2. Now it says, is 11 less than 7 times the middle? So let's take 7 times the middle, which is 7 times the quantity x plus 1. And now I have to take 11 less than that. So let's just step back and make sure this makes sense, right? The product of the smallest and the largest, okay, x times x plus 2, is equals 11 less than 7 times the middle. So 7 times the middle is 7 times the quantity x plus 11, and then plus 1, and then subtract 11. So that's going to give us x squared plus 2x equals 7x plus 7 minus 11, which is going to give us x squared plus 2x equals 7x minus 4. I'm going to move the terms in the same step. So I'll bring this up here now. I get x squared. What do we got? Minus 5x plus 4. We should be able to factor that pretty easily. X minus 4 times x minus 1. So now I get x minus 4 equals 0. I get x minus 1 equals 0. So one of my solutions is 1, and one of my solutions is 4. So again, guys, as I said, we're going to have quite a bit of work to do here because I have to do this, but I also have to do it again for my second solution set. So one of my solutions is that x is equal, let's start with this one, right? X can be 4. Well, if x is 4, then x plus 1 is 5, and x plus 2 is 6. So one of my solutions is 4, 5, 6. The other possibility is that x is equal to 1. And my other solution set is 1, 2, 3. Right, so these are my solutions, right? So the question says, what are the two sets of integers? We would say set 1 is the numbers could be 4, 5, and 6. Set 2 is that the numbers could be 1, 2, and 3, right? So if we just check the 4, 5, and 6, the product of the smallest and the largest is 24. That's 11 less than 7 times 5. Well, yeah, that's 11 less than 35, 24. And if we check the second one, the product of the smallest and the largest is 3. 7 times the middle one is 7 times 2 is 14. 11 less than 14 is 3. So we can see pretty easily that they both should check. All right, so this is one that's been on there a couple times as a multiple choice question. So I'm not actually going to do it out. It says, it was a multiple choice question that says, what equation can be used? So the question says, two brothers have ages that are consecutive odd integers. If the product of their ages is 443, what can be used to find the younger? So if x is the younger, the older would be x plus 2. So what we would do is we would say x times x plus 2 is equal to 483. Now what they sometimes do to kind of trick you is they'll say, what equation could we use to find the age of the older brother? Well, if x is the age of the older brother, we'd have to realize that the younger brother would then be x minus 2. And we do x times x minus 2 equals 483. So you just have to be careful. The problem itself is not hard, but it's just we need to remember that consecutive even or consecutive odd have a difference of 2. So x and x plus 2 and x plus 4, or x minus 2 and x minus 4. All right, so as always, guys, right, it seems like a lot of you guys are doing the now tries, which is really good. If you like, you could send it in if you're not sure, if you can send it in a message to me, because sometimes I go over it, sometimes I don't. You can post it on the page if you'd like. So again, guys, if you're doing the classwork, you'll hit pause here, and then we would unpause, and then we'd be ready to go over it. So let's talk about the first one. I've got my 3 consecutive integers, so I'll keep it simple with x plus 1, x plus 2. And I'll set up another place here to put the second group. And it says 3 times the sum of the smallest and the largest. All right, now we really have to start thinking here. So 3 times the sum of the smallest x and the largest x plus 2. So some people would use x and x plus 2 in parentheses and then use braces around the whole thing. You guys know I don't use parentheses unless they're really necessary mathematically, because a lot of times you end up distributing things that don't need to be distributed because of the parentheses. So I've got 3 times the sum of my smallest and the largest is 7 less than the square of the middle. So this is an example where if I was doing this, me personally, I would make x the middle one. I don't want to square x plus 1. How many of us are going to make mistakes and put x squared plus 1 instead of x squared plus 2x plus 1 because we're not going to expand it, right? Most of us are probably still going to do that. So for me, it would be easier to make x the middle one. Just, for the sake of not confusing people, I'm going to leave it like this. So I've got 3 times the quantity 2x plus 2 Now remember, when we're doing x plus 1 squared, it's x plus 1 times x plus 1, so we will have a middle term. I know you guys all just like to square both of those terms and leave it as is, but we do have the 2x in the middle, and then I've got my minus 7. So I've got 6x plus 6 equals x squared plus 2x minus 6. So I'm going to move my terms to the right. And it doesn't matter which side it's on. We just want x squared to be positive. Having x squared being negative is really going to be very difficult to factor. All right, so we should factor this as x minus 6 times x plus 2. So I get x minus 6 equals 0. I get x plus 2 equals 0. So I can cut to the chase here. X is 6 and x is negative 2. And again, it is really important that we go back and we sub in our values. So one set of solutions would be 6, 7, and 8. Another set of solutions would be negative 2, negative 1, and 0. All right, now the second one is really important because it just says the dimensions, right? So this is one where we're going to be introduced to something that we haven't seen yet. And we will see it, for those of you that maybe didn't get this far. We will see it, but it is important that we see it here as well. So it says the length of this rectangle is 4 more than twice the width. So I've got x and I've got 2x plus 4. Now it says the area is 96. So that means length times width equals 96. All right, so that's my quadratic. So I get 2x squared plus 4x equals 96. So 2x squared plus 4x minus 96 equals 0. Now remember, we are not going to use the 5-step method unless we absolutely have to, which in this case we do not. We're going to divide out the 2, which will give us a pretty simple quadratic equation in standard form. So that's going to factor down as x plus 8 times x minus 6. So one equation is x plus 8 is 0 and x minus 6 is 0. All right, so here it is, right? We have not seen this yet. So with the consecutive integer problems, consecutive integers could be positive, they could be negative, and 0 could be included. The problem here is I can't have a side length that's negative, right? So I can't have this width be negative 8 and have my other dimension be negative 14. That does not make any sense. So what we do is we reject this negative value, okay? That is the actual mathematical terminology. It does get rejected. Okay, it is what's called an extraneous solution. Extraneous means extra or unnecessary, not needed. So technically it's called an extraneous solution. You don't necessarily need to know that. But if this was on the Regents, and yes, it has showed up, you are going to write the word reject, right? If you substitute and you say one of the dimensions is negative 8 centimeters, that's going to be a pretty big deduction. Okay, so it's going to be this solution only. So when we go back and we substitute, we say x is equal to 6 centimeters. And we say 2x plus 4 is 2 times 6, which is 12, plus 4, which is 16 centimeters. And if we want to check it to make sure the area is 96 square centimeters, we would substitute and it would check. All right, guys, so we'll be back tomorrow. Actually, for the next 3 or 4 days, we'll continue to explore solving word problems using quadratic equations.